Hi friends, welcome to this class on polynomials, and I'm going to make the concept really easy for you. So we are going to talk about the basics of polynomials. So stay tuned for this maths class and be sure to watch the entire video. And guys, if you haven't checked out our website, do check it out. So this is our website, manochaacademy.com, and I have some great news for you. So just today we've launched the CBSE Chemistry Class 9 course. So guys, can you see this course out here? So we've launched this course today. So for those of you who are in Class 9, we have now the Chemistry CBSE course for you. And we also have the Physics courses for Class 9 and 10 for Physics and Chemistry, and also the Physics CBSE Class 9 course. So guys, do check it out. I'll put the links below, and we have big discounts going on. So do check out our courses. They have interactive videos. You can attend special live classes. There's quizzes and questions, and you get direct replies from me. All right. And guys, if you haven't subscribed to our YouTube channel already, hit the subscribe button right now and click on the notification bell so that you don't miss out on these live classes or new videos that we upload. And guys, be sure to hit the like button for this video and share it out with your friends. So good evening, everyone. I see a lot of folks are out here. So yeah, thanks for subscribing, guys. And it's really great to read everyone's comments. So big thanks from the whole Manocha Academy team, and please share it out with your friends so that we have more people on our Manocha Academy family. So guys, are you excited for this maths class on polynomials? So let's start. So first let's get the basic terms right? So what is a constant and what is a variable? Okay guys, so what is a constant? So constant is something which has a fixed numerical value. So can you guys give me some examples of constants? So what are constants, guys? So let's write down some examples here. Okay, 6, very good. 6 is a constant. 3 we can say, right? 2 or -2, right? Very good. So these are all numerical values that are constants, and even a square root of 2, because these values are fixed. They don't change. Okay. And what is a variable? Variable is something that can change. So for example, we use the notation X, right, in maths, or Y, or Z, or if you're using the Greek letters, right, alpha, beta. These represent variables which can take different values. Okay. So they can take certain because they can change and they can take different values. Clear? So this is what is a constant and what is a variable. Now let's be clear, what is an algebraic expression, guys? So combination of constants and variables that are connected by by these operations, right? So some of these operations or all of them. So plus, minus, multiplication or division, right? These operations, so when they are used to connect the constant and variables, we call it an algebraic expression. Okay, so you're connecting constant and variables using these operations. So we say that terms are separated and these terms are separated by a positive or by a plus or a minus. Right, guys? So now can you tell me the first question, how many terms do you see in this algebraic expression? So here we have an example here for you, 4x squared plus 5x y minus 2. So guys, can you tell me how many terms are there? And note that terms are separated by plus or minus. Okay, so very good. I see a lot of people are interacting. That's the goal here. I want all of you to try, guys. So go ahead and tell me how many terms do you see here? So I want everybody to try, guys. Very good. Excellent. I see the right answer here. Superb. So there are 3 terms in this algebraic expression, right? Can you see the 3 terms here? 4x squared, 5xy and 2, because they are separated by this plus. Can you see the plus here? So they're separated by the plus and the minus. Okay, excellent, guys. So now in the second question, can you tell me how many terms are there in 5x squared yz divided by 3x? So how many terms, guys, do you see in this? Okay, so some of you are saying 1, some of you are saying 2. Okay, 1 term, 2 terms, guys, decide. What do you think is the answer here? So note that what is the key point? That terms have to be separated by only by a plus or a minus, right? So everything can be combined using plus, minus, multiplication or division, but for each term it is only separated by a plus or a minus. And here guys, you can see that there is no plus or minus, we just have a division here. And of course these are x square by z, these are all multiplied within, right? So we just have a division here. So that's right, very good. A lot of you have got the correct answer. There's only one term here because there's no plus minus. So it's just a division, and this entire thing is just a single term. So this is one term. Very good guys. And so when we write an algebraic expression, for example, if you see this, we say that this is the first term, right? This is the second term, and this is the third term, right? So we can give the terms certain numbers. Okay, very good. So you got the concept clear. Don't confuse with all the operations. The terms are separated only by a plus or a minus. Great. Now let's see. So we talked about constant and variables and algebraic expressions. Now let's learn what is a polynomial, which is the topic for today's class, right? So polynomial, if in an algebraic expression, if powers of variables are non-negative integers, okay? So when you take an algebraic expression, if the powers are non-negative integers, which in other words, you know, we can say they are whole numbers, right? So what are non-negative integers? So you can have 0, 1, 2, 3 and so on. So if the powers of the variables are these, then it is a polynomial, right? So let's take a look at some examples here. So guys, take a look at the first example, x cubed minus 4x squared plus 6x minus 1. Okay, so what is the variable here? Here you can see the variable is x, right? X is our variable. And now follow the powers here. So it's x to the power 3, right? So that's a whole number. Then you have x squared here. And x is basically x to the power 1, right? So can you see that all the powers are whole numbers? So this is definitely a polynomial. That's why it's an example of a polynomial in x, right? And guys, so this is a polynomial in x. And look at the next one. So is the second example also a polynomial, right? Because can you see here the variable is y here. And you can see that all the powers, y to the power 4, y cube, and you have y, which is y to the power 1. So these are all non-negative integers. And we don't care about 2 by 3 because there's no power of y, right? In that case, so this is a polynomial in y. The second one, right? Clear guys? So get your concepts clear so that you're not confused by these terms, because a lot of these are asked in the multiple choice questions where you really need to understand the terms in the chapter, these basics, before you proceed to the chapter. And that's going to be the focus of the class, to really understand polynomials completely, right? And be crystal clear about it. So this was our definition, and now I have this question for you. Which of the expressions below are polynomials, right? So can you find the polynomials here, and let me number them for you. So this is number 1, 2 and 3. So guys, take a look at your screen and tell me which of the expressions below are polynomials. And I have the definition up here for you. So all of you can see the definition here, right? So take a careful look and tell me, what do you guys think are polynomials? Okay, so some people are saying 2, 1 and 3. Okay, some are saying 3. So take a careful look guys. Remember, the powers of the variables need to be non-negative integers, whole numbers. And it's great to see all of you participating, right? I really enjoyed. I'm looking at the chat here, guys. So come on, all of you try. And guys, if you haven't hit the like button for this class, please hit the like button right now and do share it with your friends. So take a look at my question, and which one do you think of these expressions? So we call them algebraic expressions, and they are polynomials only if it satisfies the above definition there. Okay, so let's go one by one and you guys check your answer. I see a lot of answers here. It's really great to see that. So let's go ahead and look at the first one here, right? So first one, you can see it's x squared. So that's a whole number. this is x to the power 1. But if you look at this term, 1 by x is basically the last term is x to the power minus 1, right? 1 by x is nothing but x to the power minus 1, and that is a negative integer. So the first one is not a polynomial. It's just an algebraic expression. Okay guys, now go to the next one, right? So do you guys agree with me? Because there's x to the power minus 1 negative part, it's not a polynomial, right? Now let's take a look at the next one. 2y square plus root 2y minus 30. So if you look at the first term, it's y square. So that's okay, 2. This is y, or basically y to the power 1, right? And minus 30, there's no power of y, so we don't look at that. So can you see the second one, guys? Very good. I see Dhruv Gupta says 2 is right. Okay, so great. So this one is correct. Very good. Srinivas also says that. So 2 is definitely a polynomial because non-negative integer. And guys, now you take a look at 3 and tell me, is 3 also a polynomial? Okay, so if you look at 3 carefully, what do we see here? It's basically, so this is, the first term is 2 root x. So root x we can write as 2 into x to the power half, right? Guys, you know this, that root x means x to the power half. Okay, and there you can see that a fraction has come. It's not an integer power, so therefore this one is not a polynomial. So very good, those of you got it. The only polynomial here is number 2. Okay, clear guys? Excellent. Let's move on. So is everyone clear about that? All right. Now let's talk about the coefficients in the polynomial. So if you take a look at this polynomial I have given there, right? And this polynomial contains both variables, x and y, as you can see. So it's 7x cubed minus 5x squared plus 3x minus 2. So in this, you can see here's an example. The coefficient of x cube is 7, right? So coefficient of x cube means, so if you look at x cube, the part that's remaining in the term, right? Can you see? 7. So we say 7 is the coefficient of x cube. So guys, can you tell me what is the coefficient of y in that polynomial? Okay. So who can tell me what is the coefficient of y? And hint is, it is the part remaining, the remaining part in the term. Okay. So all of you try. Some of you are saying 5x squared, some are saying 5. Okay. So see, there's confusion, and I want all of you guys to be crystal clear, right, about these terms so that you find maths absolutely easy. So guys, come on, try out this. So what is coefficient of y? So how will you solve this? Very simple. So if you take a look at y here, so this is y, and what is the remaining part? So let's mark the remaining part here. So the remaining part is not just 5x squared, but the minus sign also. Okay. So don't forget to take the negative sign. That's a common mistake. So the coefficient of y is minus 5x squared. Okay. We don't write, if it's positive, we don't write plus 7, right? But the negative sign has to be written. Okay. So minus 5, the part remaining from y. Very good. And let's take a look at what is the coefficient of x here. Or sorry, what is the coefficient of x squared? The next one. Okay. So if you look at again at this term, right? So the term here was given as minus 5 x squared y, the second term, and they're asking what is the coefficient of x squared. So we'll look at that and see what is the remaining part. And the remaining part, guys, you can see simple, it's minus 5y, right? So the part that remains, very good. I see a lot of you written minus 5y, and note guys, it's not minus 5. You have to include the y. So in that term, whatever is remaining, clear? Okay. Now what is the coefficient of x here in this polynomial? Right? So guys, what is the coefficient of x? Okay, very good. So some of you have written the answer, the part which remains, and that's 3. Great. And the constant term, right? So the constant term, remember, there's no variable here. It's a fixed value. The constant term is again not 2. It's going to be minus 2. So what is the moral of the story? Don't forget the sign. Okay? Because in these coefficients, you have to include the negative sign if it's there. So guys, it's not 2, it's minus 2. Clear? Excellent. Now let's talk about, okay, this chapter is full of so many terms, right? So now let's talk about what is the degree of a polynomial, okay? So for polynomials in one variable, that means if it's just x in the polynomial or just y, the highest power of the variable is the degree, right? So the highest power that the variable takes in the polynomial is the degree, okay? So guys, can you tell me for the first polynomial here, so for 2x plus 5, what is the degree? So we are writing down the degree of these polynomials. So who can tell me what is the degree of the first one? Wow, you guys already have the answer. You guys rock. Very good, because you can see it's 2 into x, 2 times x to the power 1. Okay, so fantastic guys. So it's simple here, degree is 1. So that's why get your concepts and definitions clear, then all these questions will seem really easy to you. And guys, can you tell me what is for the second one? What is the degree of the polynomial? And note this polynomial is in y. It can be in x, y, whatever variable. So guys, what is it? Excellent, excellent. I see the right answer here. The answer is 4. Clear? So degree is the highest power of the variable. Can you see the highest power here? Y to the power 4. And here the highest power is x to the power 1. Right? Don't forget it's x to the power 1, not just x, right? So great. Now if you have polynomials with more than one variable, so sometimes you might see this in your books, right? So can you see this example over here? It is a polynomial in x and y. So not just one variable, there are two variables here. So how do you define the degree of that? So what is the technique? Let me show you. The definition is you need to find the sum of the powers of the variables in each term, right? And then the highest power is going to be the degree. Okay, so guys, let's do this one together. So take a look at this polynomial and we need to find its degree. And note the interesting thing is it's a polynomial in two variables, right? It's a polynomial in x and y. Clear? Right? So this is a polynomial in x and y. Okay, so let's look at our first term here. So 2x cubed, right? So we need to find the sum of the powers of variables in each term. So here there's only the variable x, right? So we can write what is the degree of this term, right? So we can say the degree here is 3, right? Okay, because it's right, x to the power 3. Now take a look at this term. So if we just look at this, what would the degree be of this term, right? 2 plus 2, because it's x squared and y squared. So we need to add the powers. So we need to add 2 plus 2. So that's 4. So you can write it clearly like this so you have no confusion. Then 3xy, it's going to be degree 2 if we look at this term. And this one is going to be degree 1, right? Because it's y to the power 1. Very good. I see a lot of you have the right answer. So what is the highest power out of all the terms? And guys, you can see that the highest power is 4, right? Because in that second term, can you see? It's x squared, y squared, so 2 plus 2. Therefore, the degree of this polynomial is going to be 4. Clear? Very good. Excellent. All of you got that. Very good. So now we can give the polynomials names based on the degree, the highest power that we talked about, right? So I have an example here for you. So if we say we're looking at a degree 1 polynomial, it's called a linear polynomial. And here's an example, 2x plus 5, right? If you're looking at a degree 2 polynomial, right? So let's take an example. Let's say the polynomial is x squared plus 3x minus 4. Okay, so this is called a quadratic polynomial. Do you see that? It's a quadratic polynomial because it's the degree is 2 here. The highest power is 2. When the degree is 3, it's called a cubic polynomial. So an example would be something like 2x cubed, right? Minus 5x squared plus 3x minus 1, right? Whatever example. But here you can see the highest power is 3. So it's degree 3, it's called cubic. And similarly, if the degree is 4, it's called biquadratic. Okay, so let me write an example. Let's say x to the power 4 plus x cube, right, minus 3x square plus 2x plus 7. So this is a biquadratic polynomial. Clear? Because the degree is 4. So you need to learn these terms and names so that you won't get confused. So there are a lot of terms in this chapter, right? And so these was the names of the polynomial based on degree. Now you can give the names based on the number of terms also in the polynomial. Okay. So guys, if you look at if a polynomial has 1 terms, remember we talked about the terms are separated by plus or minus, right? By an addition or subtraction. So by plus minus, if it has only 1 term, like for example, if you have these polynomials, right? Let's say a 2x or a 5, right? The constant term, or 4xy, right? These are all known as monomials, right? Mono means 1, right? So these are called monomial, right? And now if it has 2 terms, like if you take a look here, 2x plus 5, right? Or can you see there are 2 terms, 2x and 5. Then if you look at this example, 3x square and 5x. So there are 2 terms here. This is called a binomial. Bi means 2, right? And similarly, you can see trinomial. Can you see that, guys? It has 3 terms here. Okay, very good. And now there are some more terms of things in polynomials. You have something called a constant polynomial. So something which just has a constant, right? So even 2 is considered a polynomial, but it's called a constant polynomial because there's no variables there. So these are some examples for you. So here I've written down these examples, right? So 2 is a constant polynomial, or minus 5 or 7, right? These are examples of constant polynomial. And 0 polynomial, a very special one, guys. This is just the number 0, right? Okay. So now can you tell me an interesting question? Let me ask you, what is going to be the degree? So what is the degree of constant polynomials? So these guys. So who can tell me what is the degree of the constant polynomial? So let's say you take the example 2. What is the degree? Okay. Very good. Excellent. I'm seeing a lot of answers here. Some of you are saying 0. Some of you are saying 1. So guys, decide. So my question is, what is the degree of a constant polynomial? And let's take the example. Let's say 2 is a constant polynomial, right? So let me write it here. So for example, the number 2, that's considered a constant polynomial because it's just constant, right? Very good. So a lot of you got the right answer. The answer is the degree is going to be 0, right? The degree is 0 because you can think 2 is basically 2 times, if you think it this way, x to the power 0, right? X to the power 0 is 1, right? So that's going to be 2 into 1, right? And so the power of the variable is 0 because x is not there, so it's x to the power 0. So you can know that, you can learn that constant polynomials have degree 0. Very good. And guys, what is the degree of the 0 polynomial? Who can tell me that? So what should I write as the degree of the 0 polynomial? Okay. So 0 polynomial is a special one, and what do you think its degree is? So some of you are saying 0, some of you are saying 1. Okay, it's great to see all of you trying that, right? So let me give you a hint, right? So if 0, I can say, so if you take this number 0, so I can say this 0 can be 0 times x square. So dot means multiply, right? So 0 times x square, or it could be 0 times x cube, or it could be 0 times x to the power 1, right? So what do you think is going to be the degree here, right? Very good. I see Mamta, right? Manjita, they've got the right answer. Oh, some of you saying infinity. No, guys, it's not defined, right? Because it could be anything. As you can see from my examples, it can be 0 can be 0 times x square, or 0 times x cube, or 0 times, I don't know, x to the power 7. So the power of x is the degree. Remember, the power of x is not defined here, right? So very good. Sorry if I missed your name. Some of you did give the right answer. The chat scrolls really fast. So excellent, guys. Remember this very tricky question. It can come in the MCQs. Constant polynomial, they have degree 0. And I showed you a simple example. but the zero polynomial, this special guy, is not defined. The degree is not defined. Fantastic, guys. Okay, so now let's talk about what is the zero of a polynomial, right? We're not talking about zero polynomial, that's done, right? So now we're going to talk what is the zero of a polynomial. So let's discuss that. So before we talk about that, let's take this polynomial here. Let's take a simple polynomial px as 2x minus 4. Okay, so how do we find p of 1? So what is p of 1? Very simple. You just have to take the polynomial. So we just need to substitute. So we just need to substitute x equal to 1 in this polynomial. That's all, right? So it's going to be 2 times 1, right? Minus 4. So what is p of 1 going to be? Very good. You guys got it right. So we're just substituting the value. So 2 minus 4 is minus 2. Simple. Now what is going to p of 2, right? So if you look at the notation, basically the number that's given in the brackets, right? We are just substituting because x is taking this value, the variable x. So again, we just have to substitute. So 2 times 2, right? So it's going to be 2 times 2 minus 4. And what do we get? 0. So basically we've got here that p of 1 is minus 2, p of 2 is 0. And similarly, we can find p of 3, p of minus 1, minus 2, right? So we can find these values, right? So what is the basic trick? You just substitute it into the polynomial, okay? So now if we take this polynomial px, right? Or any polynomial, if we take px and we equate it to be 0. So guys, carefully follow me here. So if we take the polynomial px, right? And we say set that equal to 0, we are basically forming a polynomial equation, right? Can you see? This is called a polynomial equation because the polynomial is just the expression, right? 2x minus 4. But when you say it is equal to 0, an equation must have the equal to, right? So we are forming a polynomial equation here. This is called the polynomial equation, right? So for example, if we take our example 2x minus 4 equal to 0, so this is our polynomial equation for our example px equal to 2x minus 4. Clear? Now, based on this equation, we can say what is 0 of the polynomial? It is that value. So that value of x, right, which makes the polynomial 0. So that value of x which makes the polynomial 0. Okay. So guys, so basically that value of x for which px becomes 0. So guys, can you tell me what is the 0 of this polynomial, our example here? So we are talking about this example right on top. So what value of x, because we know we can substitute different values, what value of x makes it 0? Excellent guys, superb. I see Shashank Kulkarni, right? Susanta, you all have the right answer. Very good guys. So the answer is 2, because as you can see in our example here, so when we do p of 2, if we calculate, for that value the polynomial becomes 0. So 2 is called it is the 0 of the polynomial, right? So that value which makes the polynomial 0. Clear? So this is called the 0 of the polynomial, and we can define it clearly like this. So we can write generally that if px is a polynomial, then if p of a equal to 0, so if we take any polynomial px, right, and we set then pa is equal to 0, then a is basically called the 0, or it's also known as the root of the polynomial, or 0 root of the polynomial equation. Okay guys, is it clear? So this is a very important term. Don't confuse this with the 0 polynomial. This is 0 or root of a polynomial, and that value of x, which basically, so you can learn it like this, that value of x which makes the polynomial 0, and this is the formal way of writing it. Okay guys, clear? Very good. So now let's try this question. So if you are given px equal to x square plus 3x plus 5, guys, can you quickly calculate p1 for me? So let's do the two parts, find p1 and p minus 2. So I want all of you to try. This is a maths class. So guys, get your pen and paper ready and go ahead and try it. Or maybe if you want to do it mentally, right? You can do that. So come on, I want all of you to find P1. So what is P1 going to be? And how do we calculate it? Very simple. It's so easy. You just have to substitute x equal to 1 in this polynomial, right? So what will P1 be? So simple. It's going to be 1 square plus 3 times 1 plus 5, right? So what is everyone getting, guys? So that's basically equal to 9, right? 1 plus 3 plus 5. Okay, excellent. Clear? And similarly, guys, we can also do P of minus 2. So we need to substitute minus 2 in the polynomial. So guys, what are you getting for that? So minus 2 whole square plus 3 times minus 2 plus 5. So what is that going to work out to? This is 4 minus 6 plus 5. So come on, check my calculation in case I'm doing something wrong, right? So guys, what is the answer here? I think a lot of you got the answer 3, right? 9 minus 6. Very good. So as simple as that, sometimes you get these really simple questions. So it's just substituting the value, right? The value given in the bracket as x. Okay, very simple, right? Now try this question, guys. Find the zeros of the polynomial, where polynomial can be given px, right? We denote it by the symbol px. So the polynomial given to us is x square minus x minus 6. Okay. So guys, can you see this is a quadratic polynomial because the degree is 2. So find the zeros of this polynomial. Come on, I want all of you to try this question. Right? And what do we mean by find the zeros, guys? As we learned, it's very simple. To find the zeros, you basically have to form the polynomial equation, which basically means px equal to 0. Right? So we set the polynomial equal to 0. So that's our equation. So we say x square minus x minus 6 equal to 0. And so to find the zeros of the polynomial, basically you need to solve the equation for x, right? So what is the meaning of zeros of the polynomial? You solve the equation right here. So to find it, you need to solve for the values of x, right? For which px is 0. Clear? So this is how you find the zeros of the polynomial. So guys, come on, solve that equation. It should be pretty simple, right? So for what values are you getting this? Okay, very good. I'm seeing some right answers there. So how do we solve this, guys? So we basically need to factorize this equation, right? So what are the factors going to be? X plus 2 times x minus 3. Right? So guys, can you see what are we doing? To find the zeros, we are basically factorizing it to solve it, right? So now you can see, so either x plus 2 can be 0 or x minus 3 can be 0, right? Simple. So what do we get here? X equal to minus 2 or x equal to 3. Okay, guys. So check my answer. Did I do some mistake, right? Is my answer correct, guys? So what have we found? So these are the values. So these are called the zeros of the polynomial. So the zeros of our polynomial are basically going to be minus 2, comma 3. Those values of x for which the polynomial becomes 0. Okay. And guys, if you're having a doubt, just follow me. Very simple. So we've been given this polynomial px, right? Okay, some of you are having a doubt. So, all right, I'm repeating. X square minus x minus 6. This is our polynomial. Our goal is what? Always look at the goal, right? Just like what's the goal of in your life, right? So you should always work with the goal in mind. So what is our goal? We need to find the zeros. So basically we take the polynomial and set it equal to 0. That's what we want. And we need to solve. So we've got this equation, x square minus x minus 6 equal to 0. Now basically we need to solve the equation. So that will give us the values of x for which it's 0, right? The polynomial is 0. And how do you solve it? You just factorize it, right? And you do that. So what do you get? X plus 2 equal to 0 or x minus 3 equal to 0. And then basically you get these values. Clear? So we get x equal to -2 or x equal to 3. And those are basically our zeros of the polynomial. Very simple. So once you get the concept, it's really easy, right? And guys, if you have any doubts, you can put it in the comments below or go back and watch the replay of this class. And I think you'll get these concepts pretty clear. Now find the zeros of this polynomial, right? So remember last time it was called px. This time it's called fx, right? You can use any notation, px, fx. You can even have gx, right? Whatever letter you want to use, doesn't matter, right? So it's a polynomial in the variable x and we need to find its zeros. So come on, I want everybody to try this. Use the concept we learned. Very good. Some of you are already writing the answers. Wow, you guys are really fast. Okay. So how do we do this, guys? Remember, to find the zeros, basically, we need to set the polynomial to 0 because we want to find the values for which the polynomial becomes 0. So this is our equation, x squared minus 3x equal to 0. This is the important thing, right? This is our equation. Please take a look. So very simple. To get the equation, just put it equal to 0. Clear? Now you need to solve for the values of x. So how do we do that? So again, we'll factorize this. So it's going to be x times x minus 3 is equal to 0. Okay, right? And so this polynomial, guys, what degree was this polynomial? Okay, can you see it was a quadratic polynomial because it's degree 2, right? X square is there and we are solving this. So we can say either x is equal to 0 or x minus 3, right? So either x is 0 or x minus 3 is equal to 0. Okay, because either this term can be 0 or this term. Right, guys? And so either x is 0 or x is equal to 3. We take the minus 3 on that side. So what are our zeros of the polynomial? The values 0 and 3. Excellent. I see a lot of you got the right answer. So zeros of this polynomial becomes 0, 3. Clear? Okay. And you can go and double check it also, right? If you want to check your answer, what do you need to do? A very simple way to check the answer. You take f of 0. So let's find f of 0. So that's going to be 0 squared minus 3 times 0. See, we are getting 0. And take again f of 3. So go back and substitute it. So f of 3 we've taken. So that's going to be 3 squared minus 3 times 3. So 9 minus 9, again 0. So see, guys, you can quickly confirm your answer, right? So whatever values you've got, go ahead and substitute it in the polynomial and basically you should get 0 because your goal was to find the zeros of the polynomial. Okay. Now go ahead and try this question. How do you prove that 2, 3 are the zeros of this polynomial? Alright guys, everyone, I want you to try this question. And you guys have been superb, really interactive, and you're answering so many questions, right? So it's great to see that in the chat, guys. I really find that awesome that everyone's participating in these sessions. So go ahead and try this question. And if you haven't hit the like button, please hit it right now and share it out with your friends so that we can have more folks on these sessions. Okay, so how do you prove that 2, 3 are zeros of x squared minus 5x plus 6? So somebody is saying by factorization, somebody is saying by verification. Okay, so how do we find this, right? Okay, so actually you don't need to factorize here. This question is pretty simple. So we'll just do, I think someone said that correctly, I missed the name. So by verification, right? Right? So what do we mean by verification? To prove that these are the zeros of this thing. So first let's write the polynomial clearly. So our polynomial fx is basically, so always write it clearly, fx equal to x squared minus 5x plus 6. That's our polynomial, right? And we need to prove that 2, 3 are zeros of it. So what is the verification? Basically we need to find, let's say if 2 is a 0 of the polynomial, then we find f of 2 and that should turn out to be 0, right? So let's check that. So what is f of 2? 2 squared minus 5 times 2 plus 6. So that's going to be 4 minus 10 plus 6, right? And guys, you can see it's 0. So we have verified since f of 2 is 0, therefore absolutely right, 2 is a 0 of the polynomial. So this is called by verification. You don't have to factorize that. You just need to substitute it, right? Just like in the previous question, we were verifying our roots. You saw that we did that? So the same technique here, right? Similarly, guys, you can try it for the f of 3, right? So to verify that 3 is a 0 or a root of the polynomial, we find f of 3. So that's going to be 3 square minus 5 times 3 plus 6. Okay, so that's going to be 9 minus 15 plus 6. And guys, again, we get 0. Okay, so f of 3, very good. A lot of you are doing that, you're calculating. So this is a very simple question, very easy to verify, right? It's like almost a giveaway thing that you just substitute and check it, right? And you can see we've clearly verified these are the zeros of the polynomial. All right, excellent, guys. And now I have an interesting question for you. Find the zeros of the polynomial fx equal to x squared plus 5x minus 14. Okay, and this is your homework question. So I want you to write the answer in the comments below, and I promise to reply to your answers as soon as possible. So guys, we won't discuss this question because I want everyone to revise the polynomial chapter, be clear about all the different terms we've learned. We talked about zeros, right, of the polynomial, and do write your answer in the comments below, right? And in a future class, we'll talk about the remainder theorem, the factor theorem. So I won't go into that in this class. So guys, go ahead and try this question and do write your answer in the comments below. I look forward to reading your comments. And guys, as I said, we've got this website, manochaacademy.com. So do check it out. And just today we launched this new course, right? The chemistry CBSE class 9 course. So guys, those of you who are interested, you can check it out. These courses are very useful for you for your preparation, and we have big discounts going on. So do take a look. I think you'll really find them really helpful, and they have interactive videos. We are going to be starting special live classes also in these courses, and quizzes and questions. So it's really useful, and I'll put the links below. And guys, if you haven't subscribed to our YouTube channel, please hit the subscribe button right now and click on the notification bell so that you don't miss out on these live classes that we are having at 8 p.m. daily on physics, chemistry, and math topics. And guys, you can give your feedback on what topics you would like in the live class. So I may not be able to take each one of them, but we can go for, majority votes and see which one is having the largest voting, right? So do put in the feedback in the comments and try this question. And guys, it's really amazing to read everyone's comments and feedback. I really enjoy reading them, and a big thanks from the Manocha Academy team. We're trying to bring you awesome content on physics, chemistry, and maths. So I hope you enjoy our videos and classes, and thanks a lot, guys, for joining into this maths class. It was wonderful seeing everyone's participation. So guys, keep practicing, keep working, and take care of your health also during this lockdown period. So I pray for everyone's good health, and guys, take care and keep your studies and preparations going. And to help you with that, we've got our website, manochaacademy.com, and you'll really find these courses very useful. So do take a look, and guys, share it with your friends. Thanks a lot. I really enjoyed the class and hope you did too. All right, guys, take care. Bye-bye. And do join us in the next live session as well. I'm hoping to see all of you there and all of your friends as well. All right, bye, guys.